This is Precalculus chapter 11, the last part of the review, the chapter review. I'm on page 774. All right, let's look at problem 50. It says list 4 pairs of polar coordinates for the point -2 pi over 4. Remember, we always start with thinking about where is pi over 4. And that would be in the first quadrant. The length of the vector is -2, which means the force is at the origin. This is pi over 4. That's the radians. But because the force is at the origin, it goes to the adjacent quadrant to make that positive. Because remember, our R value is always positive because we're thinking of it as the absolute value. It's really it's going in an absolute value direction. All right. And this is pi over 4. All right. So this is really where the vector is. Now let's think of four other polar coordinates for that point. Well, we could go from the polar axis all the way around. So that would be pi, and another fourth would be 5/4 pi. So it could be 2 and 5 pi over 4. We could go in the negative direction. If I go here, then I'm going all the way to negative pi and back a fourth. So I'm going pi and taking away a fourth. So that would be -3 pi over 4. I could go around once, which would be 2 pi, and back to here. So I would just add 2 pi to this, which is 8 pi over 4. So it would be 2 and 8 and 5 is 13. 13 pi over 4. I could take the original one and add 2 pi. So that would be -2, 9 pi over 4. -2, 9 pi over 4. Once I get one, once I get the 2, the positive and the negative, then I can just add 2 pi to any of them. All right, so that's 50, 51. Plot the points. Well, we just plotted one point, but we'll plot these. All right. Remember, in the polar coordinate system, there are these concentric circles. We'll go out 3 because 1 is a 3. So 2, 3 pi over 4. Remember, this is 0. Pi over 2, pi, 3 pi over 2, all the way back to 2 pi. So 3/4 pi is not quite to pi, and it's on the second ring. So I would plot it and label it 2, 3 pi over 4. All right, -3, -2 pi over 3. So we're going backwards. 2/3 of a pi negative goes in this direction. We're on the third ring. So it's about here. But because the R value is negative, we go in the adjacent quadrant. So this really, from here to here, is pi over 3. So we're going to go up here such that this distance would be pi over 3. And this would be -3, -2 pi over 3. All right, so for that negative, you go in the adjacent quadrant. All right, so for 50, 51 through 57, we're just going to do 52 and 53. You don't have to do 54 and 55 or just like it. You don't have to do 56 or 57. Really, the focus would be 52. When you have r is -2, it's just a radius of 2. It's just a radius of 2. It doesn't matter whether or not it's positive or negative. You're just going to go back, but it's every point. Oh, that's a 2. Every point on that circle, not a very pretty circle. All right, 53. So that's r is -2. That's 52. 53. Theta is 2 pi over 3. So r equals a number is going to be a circle. Theta equals radians. That's going to be a line. Okay? All right, at wherever 2 pi over 3 is. All right, 2 pi over 3. Remember, we're 0, pi over 2, pi. It's here. So it's a third, about a third. And this would be at 2 pi over 3. All right. Let's jump to 62 and 63. All right, it says convert. All right, so we're going to convert 3 square root of 3 from rectangular to polar. So we want to go to r theta. All right, so you draw it in the rectangular system. All right, so it goes over 3. It goes up square root of 3. I'm going to need my calculator, I do believe. I'm going to go grab it. All right, so this is the r value, and this is theta. I'm going to use Pythagorean theorem to solve for the r value. So it's going to be 3 squared plus the square root of 3 squared equals r squared. That's just 9 plus 3 is r squared. That's 11. No, that's 12. So r is 2 square root of 3. Because that is, so r is 2 square root of 3. All right, now with theta, we're going to use the tan. So the inverse tan of opposite over adjacent equals theta. All right, you have to be in radians. Huh, grabbed the wrong calculator, didn't I? Let me get this calculator in radians. All right, so second tan, square root of 3 divided by 3. So it's pi over 6. I should have known that. It's pi over 6. All right, I'm glad I put it in radians. All right, now, here's what you have to think about. What if this would have been negative? -3 square root of 3. You still would have gotten 2 square root of 3. However, when you're looking for the radians, it's always from the polar axis to here, all right? So when you get pi over 6 here, you take pi minus pi over 6, so it would have given you 5 pi over 6, all right? What if it would have been in this quadrant? And it would have been -3, negative square root of 3. Now you have this angle as pi over 6, so it's pi plus pi over 6, which would be 7 pi over 6. Now, what if it would have been in the fourth quadrant? So you have to think about your quadrants. All right, and that would have been positive 3. Now we had negative square root of 3. This would have been pi over 6. But we would have gone all the way around to 2 pi, which was 12 pi over 6, and taken 1/6 away. So we would have been at 11 pi over 6. The R value would not have changed. It would still have been positive in all 4 of these. All right? But you have to think quadrants. Think quadrants. All right, now let's look at, that was 50, 51. 51 says convert 3 negative 2 pi over 3 from polar to rectangular. So we want to go from polar to rectangular. So we want the x and the y coordinates. All right, so you graph, you start with the radians. Okay, going backwards, that's negative pi over 2. That's negative pi. So it's in this quadrant. That's 3, and all the way around here is negative 2 pi over 3. So that makes this pi over 3, because I need another third of a pi to get all the way to pi. All right, so that's a 60-degree angle. So the Pythagorean triplet is 1 square root of 3, 2. So to get from the R value to the X value, we're going to divide by 2. So it's going to be 3 halves. That's going to be my R value, my X value. 3 is going to be negative because it's on the negative axis. And also my Y value is going to be negative. So then I take this and multiply it by square root of 3. And you get negative 3 square root of 3 over 2. All right, your calculator won't give you the ratios unless you set it that way. What if it wasn't a 60-degree angle? We're going to use the tan, all right? I mean the sine and cosine. So the R value times the cosine, and I think you can do negative 2 pi over 3. Let's do that in our calculators. 3 times the cosine, negative 2 pi over 3. And it does give you negative 3 halves. So it's the R value, R times the cosine of theta is going to give you the X value. The R value times not cosine, the sine. The sine of negative 2 pi over 3 will give you the Y value. Remember, cosine goes with X, sine goes with Y. So if I do 3 times sine negative 2 pi over 3, and you get this value. All right, so when you're going from polar to rectangular, you're using Pythagorean's theorem, and you're using sine and cosine. When you're going the other direction, rectangular to polar, you're using the tan, the inverse tan, actually. All right. The next one is, that was 62 and 63. Let's do 64 and 65. What is the eccentricity of the ellipse? All right. This is 64. 24x squared plus 30y squared equals 120. All right, remember we need this set to 1. So you always divide by what that value is. And then you simplify. That becomes 1. When I simplify this, you always want the numerator to be 1 and the denominator, whatever it is. 24, I don't know if 24 goes into 120. It does 5 times. That becomes 1, that becomes 5. So it's x squared over 5 plus y squared over 4. That's my a squared. Remember, the largest value for an ellipse is your a squared. Eccentricity is the value of 2c over 2a. Remember, it's the distance between those focus points, that ratio over the distance between the vertices. Okay, I'm just double checking myself to make sure I don't have it flipped. Because, you know, I could possibly do that. Nope, that's right. Okay. So, a, the value of a is going to be the square root of 5. Now, c, because it's plus, it's going to be minus. So, c is going to be the square root of a squared minus b squared. That's just 1. So, it's going to be 2 times 1 over 2 times square root of 5. Okay, our 2's eliminate, right? And then you just multiply by, you rationalize by multiplying by square root of 5 over square root of 5. So you end up with square root of 5 over 5. My guess would be that your textbook probably does this as a decimal. So square root of 5 divided by 5 is 0.4472. Remember, eccentricity for an ellipse should be between 0 and 1. Eccentricity for a circle is 0. Eccentricity for a parabola would be 1. And a hyperbola greater than 1. Okay, so what if? Just what if? What if this, instead of that, what if we had, I'm going to write the same one, 24x squared plus 30y squared equals 24. All right, you're going to divide every term by 24. That becomes 1. This becomes just x squared. It's really over 1 plus, when we simplify this, okay, 6 goes into both of these, 4 and 5. So you end up with 5y squared over 4. But we don't want anything in the numerator. All right, you don't want a coefficient. All right, so you're going to just multiply by 1/5 over 1/5 to move that 5 to the denominator. So you end up with x squared over 1 plus y squared over 4/5 equals 1. Okay, you have to be able to do that. All right, that was 6465 is the exact same way. 67. Sketch a graph of the equation. So 67 is r equals negative 24 over 3 minus 9 cosine theta. Okay, so it's on the x axis. So when I look at theta, I'm going to look at 0 and I'm going to look at pi. I want this to be 1. It's going to tell me what shape it is. So I'm going to divide everything by 3 so that I have r equals negative 8 over 1 minus 3 cosine theta. Now I know it's a hyperbola. All right, that tells me it is a hyperbola. All right, so then I plug in 0, I plug in pi, I get my coordinate points. So r is negative 8 over 1 minus 3 cosine at 0, which is 1, all right? And then we have r equals negative 8 over 1 minus 3 cosine pi, which we know is negative 1. So r is negative 8 over 1 minus 3, which is negative 2. So r is 4. So then we have this point 0, 4, or 4, 0 rather. So we have 4, 0. That's r theta that we can plot. Here we have r is negative 8 over 1 minus a negative is a positive. So that's plus 3, which is 4. Right? 4. So r is negative 2. So now we have pi negative 2. r negative 2 pi. All right, so how do we plot these? Just like we did when we did polar coordinates, okay? I'm going to erase this. We look to the 0, we look to pi. When I look to 0, I go out 4. 1, 2, 3, 4. Here we go. When I look at pi, I go back 2. It's here. All right, so my hyperbola looks like this. Okay? Number, that was 67. Let me go back to my 73. 73 says, find a polar equation of the conic that has a focus at 0, 0 and satisfies the given information. All right. All right, so this is 73. Okay, it's an ellipse. It has vertices at 4, 0 and at 6, pi. All right, I know it's cosine because the vertices, it's on the x-axis. So I know that it's either r equals ed over 1 plus e cosine theta, or it's r equals ed over 1 minus e cosine theta. I always start with the positive. All right, so I'm going to plug in 0. This is what I'm plugging in. Both of these points. 6 pi and 4, 0. All right, so I have 4 equals ed over 1 plus e cosine 0. Cosine 0 is 1. All right, and I'm going to plug in 6 pi. 6 equals ed over 1 plus e cosine pi. Cosine pi is negative 1. All right, so we have 4 equals ed over 1 plus e. And here we have 6 equals ed over 1 minus e. All right, we're going to multiply by 1 plus e and 1 minus e on both sides. So this one, 1 plus e, 1 plus e. This one, 1 minus e, 1 minus e. So that I have 4 plus 4e equals ed. And here I have 6 minus 6e equals ed. Now, I have ed equals ed equals. I can set them equal to each other and solve for e. So I have 4 plus 4e equals 6 minus 6e This one's going to work. I'm going to add the 6e to both sides. I'm going to subtract the 4 from both sides. I'll write it over here. I end up with 10e equals 2, dividing by 10. E is 2/10 or 1/5. All right, so I have e. It's not the minus, it's plus. Remember how you know this. If this is a negative eccentricity, it's not the right one. All right? So now I've got to solve for d. I'm going to go back to this one and solve for d. 4 plus 4 times the value of e, 1/5, equals e 1/5 times d. All right? I'm going to have to erase in a minute. Maybe I'll erase the pi. All right, I'll erase it in a minute. So this is 4 plus 4/5 equals d over 5. I want to eliminate that denominator. I'm going to multiply every term by 5. So I end up with 20 plus 4 equals d. Well, d is 24. That was pretty easy. All right. Now, I'm going to just plug in e and d right here. So we have r equals, the value of e is 1/5 times d, 24 over 1 plus the value of e, right? That tells me it's an ellipse, times cosine theta. And they wouldn't leave it like this. This is 24 over 5 all over 1 plus 1/5 cosine theta. We would multiply by 5 over 5. So that this would eliminate, so it's 24 over. You have to distribute the 5 in the denominator, 5 plus cosine theta, and this would be your equation. I know that there were some more problems assigned, but let me just make sure there's nothing else. All right, we didn't do 11-7, and you don't need to do any problems further.